I'm Eric. I'm a fourth year mechatronic engineer and my summer research project is the PCB milling machine. Currently for UQ students, for a PCB to be made, the board needs to be sent overseas to be manufactured, and this method is costly and has a large waiting period. Instead, a more viable option is using a computer numerical control milling machine, which provides a fast turnaround board production process of only a couple of hours and at a low cost. The purpose of the PCB milling machine I have built is to provide a cheap and quick alternative for engineering students to prototype printed circuit boards. The whole design is inspired by a similar project conducted at MIT. The key components of the machine are the Arduino Uno, essentially the brains of the electronics itself, including the big easy driver chips, 3 stepper motors for precise X, Y, Z axis control movements, the spindle, the tool head, and limit switches. The whole design process of the PCB starts with the electrical schematic and board design produced with design software such as Eagle. From there, a ULP script called PCB G-code is used to convert the board design into usable G-code. The software on the host computer is called the Universal G-code sender, and this software sends machine control commands from the G-code to the firmware via USB connection. This is then sent to the Arduino Uno, where the firmware sits. The firmware is called GRBL version 0.8, which is an open source, embedded, high-performance G-code parser written in Optimized C. The firmware then actuates the motors to start milling. As you can see, all mechanical, electrical, and software components of this machine work collectively to automate the milling process with high precision and reliability. And here is an example of a finished milled PCB which was produced in 1 hour and at a student affordable price of just $1.